Hi guys, welcome to this channel. In this video, I'm going to be talking about one of the most important aspects of structural design, which is the structural loadings. The structural load is important because for us to be able to design any part of a structure or a building, the first thing you have to consider is the loads, or in other words, actions that are acting on that particular structures or building. So in the next couple of videos, I'm going to be making series of videos on different structural members and the type of loadings you are to consider as a structural engineer. So that is why in this video I will be focusing on slab. We all know slab to be a structural element that is considered to be that provide a flat surface. So slab can actually take different forms. So generally we can refer to slab as a normal slab. We can also refer to slab as deck. We can refer to slab as floor, and we can also have plates. When we talk about slab, generally, as to structural engineers, the term slab can actually be used for suspended slab. When you have a slab that is suspended, we generally use slab for it. Then you can also have, when the slab is not suspended, in that case you can call it a ground slab or you can call it a floor. Architecture generally refer to slab as floor. So that is why you see in their design you have what we call the ground floor, the second floor, first floor in that scenario. But when we talk about desk, this is actually a terminology that is common in highway engineering, particularly in bridge engineering. So when you want to refer to the flat surface of the bridge that actually takes the loadings, which can include the pedestrian load and the traffic load, is called the deck. Also, when we are talking of wood engineering, you can often refer to a flat surface when the structural element that you use to create a flat surface as a deck. Then in layman you can say decking. Then we also have what we call plates. Plate is commonly used in steel structures. Then you specify the thickness. So generally we are referring to the same structural element, which is a slab. And one of the characteristics of a slab that you have to know is that a slab is an area structural element. So that means when you are trying to categorize or estimate the loadings on a slab, what comes to your mind is that loading must be in an area form. So let us now look at the different type of loadings that we have generally. Generally, we have about 4 types of loading, which can actually be more than that, but the most common one. The different kind of loadings that we have include the uniformly distributed load, we have concentrated load, uniformly varying load, and also we have what we call the line load. So the differentiate between them, I actually make use of this diagrammatic representation. So this first diagram is showing a uniformly distributed load. In a uniformly distributed load, the pressure on the load or the value of that load is actually uniform across the slab, and it can actually be applied as a full to cover the whole length of the slab or the whole area of the slab. So in that kind of situation, it can be referred to as a full pressure when it covers the whole area of the slab. But when it covers just a partial part of the slab, then you can call it a partial uniformly distributed load. So when it covers just a percentage of the area of the slab. Then we also have the concentrated load. Concentrated load is not really common. When we are designing for slab, we don't really try to design a slab to resist concentrated load due to 1 or 2 reasons. So this is when a point load is acting on a particular part of the slab, so that can generate a concentrated load. We also have the uniformly varying load. This is not really common in slab, but you can find them from ground pressure on slab, though it's in a very rare situations. Even though in design, generally we used to assume that the pressure below the ground on a structural element, either beam or slab, we assume it to be uniform for easier analysis. But sometimes it might not be uniform, so it might be uniformly varying. Then we have the last part, which is the line load. The line load is when you have a segment of a load that is just acting along a line across the load. Example of this can actually be found in bridge deck when you are trying to analyze the loadings on bridge deck. And a typical example of it in building is when you have a cantilever slab and you have a wall resting at the tip of that cantilever slab. So that kind of a wall can be analyzed as a line load on the cantilever slab. So these are the various type of loadings that you can have. But practically, what are the kind of load that we consider generally on slab, especially when we are referring to building structures? So one of them is the dead load. So this dead load is also known as the permanent load. So it comprises of the self-weight of the material. So let's say your slab is made up of concrete. So that means the self-weight of the concrete itself. So if your slab is made up of steel, the self-weight of that steel member, whatever the material of construction in which your slab is made of, is going to contribute to the self-weight. Then you also have the finishes. This can apply to different kind of finish that you want to apply to your slab. Then we also have partition load. This is common in buildings. How can you now estimate the dead load of a particular slab? The dead load of a particular slab can be estimated once you determine can be estimated from the unit weight of that material. And the unit weight of most construction materials can be found in design codes. So if we are using the BS code, for those of you that design using the British standard, so you have to refer to BS 648. But if you are designing with the Euro code, you will have to check EN 1991 part 1 of 1. So another kind of loadings that we also consider in slab is the imposed load. This is general for buildings. So imposed load is also known as the live load. This is actually based on the purpose of the building. If the building is a commercial building, the load is going to be different from if the building is a residential building, depending on the purpose. Actually, we can find loadings specifications for imposed load also in the code. Either with the British code, you can have BS 6399 part 1. But if you are using the European code, that is EN 1991 part 1 of 1. So under EN 1991 part 1 of 1, you can find information about the density of materials, which is the dead load, and you can also find details on determination of the imposed load. Then the last part of load that is not really common in buildings but are important, especially when the building is to a particular degree, is the dynamic load. And the dynamic load that I'm referring to in this video is actually the wind load. So the wind load can actually be analyzed by determining the static equivalent. Once you are able to determine the dynamicity of the building, so if the dynamicity of the building is within a particular limit, you can analyze the wind load as a static load and then apply it on the structure. But when the dynamicity of the building is to exceed a particular limit, is actually given in the code, then there's no way you can represent that load as a static load. You have to design it, you have to analyze it as a dynamic load. So you can actually find specification on that for the BS users, that is BS 6399 part 3. But if you are using the Euro code, that means you have to refer to BS EN 1991 part 1 of 4. If you actually like what I'm showing you, you can hit the subscribe button and turn on the notification. I'm going to be making more videos on all other structural elements and the loadings on other structures. So let us now look at how can you now estimate the loadings on slab. In order for you to estimate, for example, the live load or imposed load, is very easy because they are already given in the code. All you have to do is just go to where you can find them in the code and pick the value. But if you want to estimate the wind analysis, if you want to analyze the wind load is not a common load that is usually applied to majority of structures, only when your building height is to a particular level, that is when you can now consider the wind load. So, but to determine the dead load for any construction material for slab, all you have to do is to determine the density of the material, and then you multiply it by the thickness. I already told you that a slab is considered as an area element. So that means the unit of load has to be in square meters, per square meters. So that means that is why the dead load is given in kilonewton per square meters. So whatever the density of the material is, multiplied by the thickness. So let us take a simple example. Let's say we have a material that has a density of 28, and in this case, this 28 is in kilonewton per meter cube. So, and then you want to determine the dead load of that material, that is the self weight of that material. So that is going to be multiply the density by the thickness. So if the thickness of the material itself is, let's say the thickness is 100 millimeters, so that is 0.1 meters. So if you do this computation, you should end up with 2.8 kilonewton per meter squared. So this is going to be the equivalent dead load you are going to apply on the slab due to the self weight. So let's say you are applying a finishes of 50 millimeters on that slab, and then the density of the finished material, the material you want to use as your finish, is, let's say, 20. All you have to do is density multiplied by the thickness, which is 0.05. So whatever this give you is going to be the dead load. I think this is going to be around 0.1. So this is 0.1 kilonewton per meter square. Then the total dead load on this particular slab is going to be the self weight plus the finish. So in some other scenario, you might have to determine service loadings. This service loading can actually include services that are permanent on the structures. This is how you can determine the dead load on the slab. In order to end this lesson, let us look at how you can simply determine the imposed load on a particular slab. So let's say the kind of slab we want to design is a domestic apartment. Like I've mentioned, the imposed or live load depends on the purpose of the structure. So if you are designing for either public building or residential apartment, all you have to do is come to because this is BS code. This is BS 6399 part 1. And you can see under 5, this is imposed floor and ceiling load on slab. So if we come to table 1, this is where you see the minimum imposed floor load. So in this case, floor is referred to as slab. So depending on the category, you can see we have different category. I think about 6 or 8 category. Category A is domestic and residential activity. So example of specific use can be seen, and then you can pick your design load. You can see that your imposed load is actually in two forms. You have the uniformly distributed one, and you also have the concentrated one. So as I said, a slab is an area member, so you pick the uniformly distributed component of it. So let's say you wanted to design for domestic apartments, and then for the dormitories and bedrooms, so you can see that the load is 1.5 kilonewton per meter square according to the BS 6399. So you can also see other categories. You have offices and work areas. You see the category of load ranges from 2 to 20 depending on the kind of specific use. You also have category C, which include areas where people may congregate. So this can include classroom, reading rooms, public and institutional library, and all of that. You can see the range of the live load ranges from 2 to 7.5. Then you also have category D. Category D is shopping areas. This is shopping malls. When you are designing floor or slab for shopping malls, the imposed load according to the European standard, the BS code, sorry, is 4.0. Then we have warehouse and storage areas. We have category F and category G. So let us look at the Euro code. For the Euro code, this is EN BS EN 1991 part 1 of 1. And then you can see this is it, EN 1991 part 1 of 1. So if you go to page 24, I think you see categories. You can see this is also divided into different categories. So we have imposed load is just quite similar to the BS code, just some little difference. So you can see that the load are also given in kilonewton per meter square as well as in kilonewton. Since you are designing for floor, which is a slab, which is a floor and area element, you pick the area form, which is kilonewton per meter square. So this goes for 1.5 if your area is a floor area, staircase or balcony. The live load ranges from 2.5 to this. So each of these category has already been defined in the table. So you can see category A, area for domestic activity, category B, office area, category C, area where people may congregate. It's very similar to the BS code. And then you have shopping areas. You also have definitions for other categories. If you read through all these clauses, you see information on the other categories. This is category E and F. This one is for storage and industrial use. So this is how you can pick your impose or live load for a particular slab and then impose it on the slab and design. So, but for the last type of load, which is the dynamic load, like I've already mentioned, the analysis of dynamic load is much more tedious compared to dead load and live load, especially for buildings. So in that case, we're not going to be covering that in this video. So thank you for watching. If you actually love what I've showed you, you can hit the subscribe button, turn on the notification. You can even share this video with your friends. Then you can give me a comment. Whatever you think about this video, leave it in the comment section. I'm going to respond to you if you have any question. Thank you. See you in the next one.